In the previous video, we have seen that Flutter is front-end and it has to talk to the backend. Now, the main question that will pop in your mind is, how can I talk to the backend? There are many ways to talk with the backend, but inshallah in this video, we are going to talk about async and await. Basically, with the async keyword, you are defining a code that is asynchronous. The difference between a synchronous code and an asynchronous code is that the synchronous code runs in a linear way. On the other hand, you have async that use the keyword await to wait for some code that will be fetched in the future. To be more clear, every time that you are writing some code is synchronous until you see the async keyword before the body of your function. In some cases is implicit, like for example when you are using future builder. All the code before await runs in a synchronous way. When it reaches the await keyword, it executes the function and it waits that it is completed. It can be completed with a value or with an error. And then after it completes, it continues with the other code. Let's take a look at the function that gets called by the await keyword. Our function should be a future. In our case, we are not returning anything because we simply are printing a value on the screen. In our example, we are simply simulating something that will happen in the future. In a real case scenario, you may want to call a server and you will want to return something. In this case, after 4 seconds, it will print something. Now, inshallah, I'm going to make a more detailed examples using some examples that you could find into the Flutter and Dart documentation. We are going to take a look at this code here. This code I have took it from the official documentation, so you can find it right there and you can run it. So now let's take a general look at this code here, and we want to take a general overview to know how the main function are put and how they works, and then inshallah we can analyze better how the single functions work. So as we can see, we start from the main, and we always have to start from the main. The main call this function here, and this function here have a parameter of 4, and then it loops and it basically prints the numbers from 1 to the number of this parameter. So it prints from the number 1 to the number 4 with a delay of I. So the first time it will take 1, 2, 3, and 4. So okay, and then after this function here, we have this one here. We have print order message, and it is this one here. If it gets called, and it basically prints awaiting user order and then fetch user order, that it is this function here, and it has this cool keyword here that means that it is an asynchronous function, and yeah, and at the end types this the order is this one. So now let's take a more detailed look. Basically, since the first function that gets called is this one here, the count seconds, and here we have a delay of those seconds here. So since we have the first delay that starts at 1, so that means that the first print of 1 get executed after 1 second, and that means that in the meanwhile we are running this code here. this is the reason why the first thing that it does, it prints this message here. Oops. This message here, awaiting user order. Then it goes into this function here, fetch user order, and since it is an asynchronous function, it will wait until this function get executed, and after 4 seconds it will return a string of this type, and the string will be inside this variable and it will get printed here. So after 4 seconds it will print that here. This is the order on how things get executed. So the first thing is awaiting user order, then prints 1, 2, 3, 4, and the order type. So with the type future, you are defining that this function it is a future, and with future we basically mean that it is a function that will return in the future, that will get executed in the future. So it will take a little bit of time, let's say, and it can take time, I would say. So, and the return type, it depends on the function. So for example, here we have void because we, in the body function, we are not returning nothing, and this is, for example, a return type of type string because we are returning a string. To make things a lot more easy, let me explain this fetch user order. So basically here with future.delayed, you basically are saying that you want a delay with the duration that you are going to indicate here, and in our case we want this function here to get executed after 4 seconds, and after 4 seconds it will return this content here that it is a string. So, and since we are not using the body and we are only using the lambda, that it is like if we type the brackets for the body and we type return before this. I hope that it is clear, inshallah, because I know that maybe it is not easy for the people that just start. And basically at the end, this function here, this anonymous function, get executed and it will return and it will be returned. And this is the reason why here it is a string. It will return as a string after the future is completed, and after everything it is okay, the string value will return and will be put inside our order. And basically you define an asynchronous code by using the async keyword. So, and you use it before the body function. As you can see here, we have the bracket, here we have the closing bracket, and in this way you are defining that this function contains asynchronous code, that it is an asynchronous function. And obviously inside your function you can and you are able to put synchronous code. So for example, here, this print here, it is a synchronous code. It is not async code because it doesn't contain this await keyword. So, and this is the other reason why here this print get printed immediately without waiting, because this is sync code. And basically, as I have read into the documentation, if I am not wrong, that in the new version of Dart, all the code before get executed until it arrives to the first await, and it stops to execute this function. So it stops here, and it waits for the value to get fetched, and after the value get fetched, this function here get executed. So basically, to say to a function that that is a future, that contains a future, that you have to wait for it, you use the keyword await, because since this function here is a future, and you have to wait that the content get printed, since this function does not get executed immediately. This fetch user here does not get immediately because you have this feature that delayed, that basically here you are only simulating a call to a server, because usually when you call a server, you don't know that server and you have to wait for it. So you don't know that server, and it depends, because maybe the server is in China, and instead if you have a server in America and you're in America and you have to wait only 10 milliseconds to get your content, maybe with a server in China you have to wait 30 seconds. Yeah, I'm a little bit exaggerating, but yeah, you have to wait a little bit, and you don't know, and you have other than this, you have you don't know if the value that you will get executed or not. And here we are only simulating this behavior by creating a simple delay, and it is like if you are calling a server. And since this function does not get executed immediately and you have to wait for it, this is why we use the keyword await. So when the function gets executed, here we'll save this content here, so large latte, and then the code continues, and in our case it will print the remaining content, and then obviously then goes back here, and the code, if there is code, it will continue. But the code that you execute will not always go as you wish. So sometimes where you are calling a server, you may get some errors. This is the reason why you have two states for the future. You have the completed with a value and with completed with error. So basically, when you are calling a server, you don't know if that server is up and running at the moment, if it has some problems, if it has some problems in that specific API. Things can be different, let's say. This is why it is absolutely essential and important that you get used to use try and catch when you call asynchronous code. And as we can see in this example, we use try and catch to wrap our asynchronous code, and this is an error that for now just simply logs the error. And in this way we are saying try this content, if it breaks, do this function here, so do this thing here. And it is absolutely important because we are going to be safe. So if things breaks down, we are safe and we want to do other things instead. Obviously not printing the error in the real world example, but we want, for example, to log the error in some place or send it in another place, and we want to continue with our application. We want, for example, to show a message. I don't know, usually when you use an application and there are some errors, you see a pop-up saying we have some troubles now, try later, things like that. And it depends on the case, and how the error is important, how the data is important in that moment, because obviously if someone tries to log in and you print some error, but you let the user log in equally, and this is not the behavior that you will want. But in some cases, the data that you are getting back, it is not really important, so it is not a problem if you show an error and the application continues and goes to the next phases. So here we have, as before, a feature of type void. We have an asynchronous function by defining this keyword here, and this is the body. We are using try and catch. So now we start from here as before. We start from the main and we call print order message here, and we basically start with the content. So we try catch, as I said before, it tries the content. If it works fine, okay. If not, it will execute this function here, and the error parameter that you have here is the error, the current error that happened. And as we said before, this is the keyword await, because it waiting for this feature here that will return a type string. It basically, as before, waits for 4 seconds and it returns an error with throw, is returning is throwing an error, and it's saving it into the string and it's returning it, so it will return here. And then it will, since we have a throw here, it will throw an error, and from here it will go right here instead of typing awaiting user order and typing the order.